A lawn service company charges $60 for each lawn maintenance call. The fixed monthly cost of $680 includes telephone service and depreciation of equipment. The variable costs include labor, gasoline, and taxes and amount to $36 per lawn. So we want to write a cost function, and they've given us C of x for x maintenance calls. Well, the cost is $36 per lawn, so that's 36 times x, and then there's a fixed cost of plus $680. So there's our cost of running this business. Now we want a linear function for the revenue, and they're charging $60 per lawn, so the revenue is going to be 60x. Now we want to next find a profit function. Now profit is what's left over when you subtract off your costs. So we're going to have our revenue minus our costs, which will be 60x minus the 36x plus 680 in parentheses, and that will equal 24x, I'm going to distribute the negative, minus 680. Determine the number of lawns needed for the company to make money. Well, they make money when the profit is positive. So we want to take that profit, the 24x minus 680, and we want that to be greater than 0, which means 24x needs to be greater than 680. And when you divide each side by 24, it turns out that x must be greater than 28 1/3. Now normally we round down, but if you round down in this case, it will be lower than the value they need to make a profit. So in these type of inequality problems, we always round up, and I'm going to say if 29 or more calls are made, they will generate a profit, or they will make a profit. Make it easier to write. In this last part, they want to know how much profit will be made if there's 42 calls. So here we go. Profit when there's 42 calls will equal 24x, which will be 24 times 42, minus the $680 of fixed costs. This will equal 1008 minus 680, which will be 328. So we will have a profit of $328 will be made.